Hi, I'm Seth Chandler. I'm a law professor at the University of Houston Law Center, and my talk is going to be on efficient and elegant extraction of data using the Wolfram language with a focus on the query command and the dataset structure.
Okay, well, thank you very much for coming, and hopefully you will be able to see this. I'm not sure why you can't see it, but I'm Seth Chandler, and I'm going to be talking about exploring a very large legal citation network, I know you can't read that either. Basically, let me just start with, there's a lot of data behind this. And there's so much data that I don't even want to try to run this live. So I'm simply going to describe it for you. I anticipate that the data will be available on the Wolfram Data Repository as soon as a few issues are ironed out, mostly relating to the size of the data and how we might want to break it up. But there are gigabytes of data here that are underlying this. So why should you care? Most of you, I assume, are not lawyers. And what I would say is that, first of all, in many fields, so you've got lots of citation networks out there, and some of the techniques that I'm going to be using here in algorithmic analysis of these networks may be useful to you. I'm going to be doing a little bit of network theory, which might be useful for some. You'll see dataset management issues that will certainly recur anytime we have large data. And I'll also, as I was yesterday, showing how one can use the query/dataset paradigm to do a fair amount of analysis of large data. If anyone in here is a lawyer, we're going to talk about how the American judicial system has evolved and how you can show that algorithmically. Okay, so this does follow on some work that I did actually 13 years ago, where I was one of the first people to look at what was then considered to be a large network, which was the citations between American Supreme Court cases. And that involved about 28,000 cases and roughly 250,000 links. But time has evolved, and now even Texas alone, we now have data from Texas, and that has 440,000 cases and 2.5 million edges, and that's been analyzed. And you can see, for example, what some of the most important cases are, or make an exciting word cloud of a particularly interesting Texas case. We have the Washington University in St. Louis has been compiling for many years a large data set looking at US Supreme Court cases. And so just so you know what can be done, I thought this might be interesting to some in light of current events, is, as many of you know, one of the swing justices on the Supreme Court, Anthony Kennedy, retired, leading to a big fight about who would be his replacement. And a purportedly more conservative judge, Brett Kavanaugh, was nominated. And so one question was, does it really matter as a practical matter? And so what I did here was to search all 4 Supreme Court decisions since Justice Kennedy was on the bench, in which the court was liberal, but only because Justice Kennedy decided to cast a liberal vote. And I wanted to see how many cases were like that. And as you can see, there are actually quite a few. And particularly in areas of criminal procedure and civil rights, there are a number. That's not to predict what Kavanaugh will do, but it does suggest that if you are result-oriented, you might be concerned about the substitution on the Supreme Court. All right, so what's available now? There are a couple of legal data sets that are available. The Washington University in St. Louis data set has been translated into, I think, a very nice Wolfram languagey format with entities and all sorts of fun stuff. And on a slightly related matter, if you're interested in the death penalty, there is now a pretty comprehensive data set on United States executions since the mid-1970s, when the Supreme Court permitted it to be restored. All right, where's this data coming from? I want to give a plug for an organization called Free.Law, which has been collecting huge volumes of legal citations and evading, cleverly, various ways that people try to make it more expensive for them to get that information. If you've never read a legal opinion, I just found one here. And what you can see is that, for example, here's a case and it's discussing blah, 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 but here's a reference to another case. And here's a reference to another case. And here's a reference to another case. And so what one needs to do is to find parsers that intelligently separate out the citations from the other stuff in the case and try to figure out what entity, in some sense, it's an entity referencing problem, does that refer to? I will say that free.law has done a reasonable job on this, but definitely an imperfect job, in part because standards for citation in the United States were not really unified until the mid-1920s, and so information that was before that, it gets a little tricky. So we've got a couple of data sets that yes? It is only US law, and they have a little bit of Old English law, but nothing much to speak of. Okay. It would be very nice if they would expand themselves to other common law domains. Australia has a pretty rich repository. UK has a rich repository. Going beyond that, you start to get into language issues. But I think they would be very interested in expanding. So we have two data sets that they had. One was a data set with links, and one was a data set describing the cases. But there was no good connection between the two, so that I might know that case number 3,473 was cited by case 1,308,000, but I wouldn't have any idea what that meant. And so I actually collaborated with them to try and put together the linking information, and for a very modest contribution to free.law, they went ahead and did it. And so I now have the related data that I want. I will say the bad news that I've discovered is that sometimes free means that it may not be of the highest quality. And one of the things I've been trying to do is to weed out errors. So for example, if a case from 1920 is citing a case from 2007, that's very unlikely to have occurred. And so a good chunk of my effort has been in trying to weed out those kind of errors. Anyway, here's what the data set looks like, and you'll see there are 4,117,000 cases in the whole thing. We've got all sorts of information on those cases. What does it cite? We have the days between the citations of that case all wrapped up in a nice Wolfram quantity array. We've got a graph which is cleaned, and after it's cleaned, it has 3,176,000 vertices and 30 million edges. And so from my perspective, we are right sort of at the edge of what my nice little MacBook Pro can do. And I think one of the issues that I need to confront and others need to confront is whether the data set Mathematica in core capability is really up to this challenge, or whether we need to move to more sophisticated backends like Mongo or other things that Stephen was discussing last night. In any event, what do we find? So if there are any lawyers in the room, these are the most cited cases, and you will recognize, I would say most people who have a law degree would recognize almost all of the top 20 cases, and they are almost all, interestingly enough, cases about procedure, either procedure in criminal cases or procedure in civil cases. And so this was at least refreshing that this was plausible. Many of you may know what PageRank is. It's the old algorithm that Google used, at least at first, in order to prioritize things that the search engine hit. And when you do that, you find a somewhat similar list. Again, these are mostly criminal procedure cases. Some of you may recognize Miranda versus Arizona or Gideon versus Wainwright. And others, though, are of more historic interests, like the good old Gibbons versus Ogden from 1824, which has persisted as a really important case. I tried to run hit centrality and cat centrality to get other measures, and I discovered either that it blew up the kernel or it exhausted my patience. So, all right, so one of the issues also is there are a number of opinions that are not technically published. They're sort of out there, but you're not supposed to cite them. And so I wanted to get rid of the unpublished opinions and see if that was biasing things towards criminal cases, because a lot of them tend to be, a lot of the unpublished cases involve fairly frivolous prisoner appeals where, they got nothing to lose, so why not file an appeal? And the answer is no, it didn't really affect very much. And so I don't think that what we see about criminal procedure cases and to some extent civil procedure cases is an artifact of publication bias. That's me just trying to figure out what it was. All right, I wondered how many lines of code it would take to replicate my 2005 work, which was this, I will say, huge effort involving JLink and Java libraries and this external program called Pagic. Doing that Supreme Court work in 2005 was quite challenging, and here it all is. If I'd only waited, that's what we would have found. And the results, although there have been new citations, are largely consistent with what I saw. And I would say that these are, you'll notice these are a little different set of cases. These are cases where a Supreme Court decision cites another Supreme Court decision. And these are on a more diverse set of topics, many of which deal with congressional power to regulate commerce, with the ability of the Supreme Court to review legal decisions made by state courts. We also have other things, Gideon versus Wainwright about the right to counsel. Murray's Lacy, I was very excited to see Murray's Lacy, which is about the ability of people who are not what are called Article III judges, meaning they don't have life tenure, to actually decide things that are really important, like whether you'll be deported or not. And what's nice is that algorithmically, we can find that those cases actually are very important. So one question I had was, my goodness, this is, this takes time. This whole thing, this is very big. Do we really need all this data? Maybe we could just sample the edges. And if I sampled the edges, really the same cases would come up. And so I don't need to be doing all this work. So here's a little graph, and what it shows is the variation of page rank based on the number of samples. And so what perhaps you can see is as we get to 1 million edges, the relationship between the mean of the page rank and the standard deviation of the page rank begins to decline. And so at least for the big cases, sampling seems to be okay. And that's probably mostly what we care about. Do I really care exactly what the page rank is of some, forgotten 1883 case out of South Dakota? Probably not. But if I did, we see that there is a lot of variation even with 1 million edges. All right, so another thing we can do is look at legal history and start restricting ourselves to see what would the law have looked like if I were, say, in the mid-60s before what's called the Warren Court came into effect and really changed, or many people think, changed the direction of American jurisprudence. And an interesting finding is, yeah, they really did change the direction of American jurisprudence. If I look at this list of cases, I do not see criminal procedure cases. I do not see civil procedure cases. I see cases about commerce. I see a case about personal jurisdiction by state courts. I see a case about federal power to create banks. There's a criminal procedure case. I see a case about discrimination, state court review, the Privileges and Immunities Clause, and a lot of stuff about federalism, actually. And so what you can see just algorithmically is the move from the time of the Warren Court from a more diverse concern about issues of federalism and congressional power to a much more rights-oriented approach in the more modern era. And so I thought that was an interesting thing that one could tease out. I attempted to go back and see, hey, if I were alive in 1900, what would this look like? And what we see is, I've never heard of a lot of these cases. And we also have the curious appearance of North Carolina. I think, and I need to track this down, I think the appearance of North Carolina is bad data at work. That is, I would be surprised if suddenly in 1900 everyone was paying very close attention to the North Carolina courts. But what you also see is cases that are not particularly familiar to us today. And immodestly, I know a fair amount about legal history, and I don't know a lot of these cases. And so I think part of this is actually the result of the inability of these scrapers to find citations. And so even though other cases may be important, the links aren't there for the algorithm to work on. Okay, so what else did I try? There's another program called IGraph, which is a glue between Mathematica and a Python-based graph program, and I wanted to see if it could do any better or differently, like whether it could run hit centrality. Turns out that actually, sorry to say, Mathematica IGraph M did run this stuff, and so you can see interesting things. So let's talk about something called, anyone know what the degeneracy of a graph is? I'm thinking making this paper called the Evolving Degeneracy of the Court System. The degeneracy of the graph is, imagine that every case in some subset of a case cites at least n other members of that subset. But that if I increase n by 1, there is no subset that satisfies that relationship. That at n, that's the degeneracy of a graph. And it's some measure, I think, of the complexity of cases. That in order to understand the seamless web of the law, you actually have to understand a huge body of law in order to get it. There's a lot of interaction going on. And so what we can see here is that the actual core, that degeneracy of the graph, actually stands at 121 cases, that there are subsets in which in order to understand the cases, you have to understand 121 others. What are they? And interestingly enough, there are a lot of cases from Mississippi, mostly on Mississippi criminal procedure, and in particular on Mississippi death penalty law. And for those who practice in that field, as one of my colleagues does, it is a particularly complex area, and it makes, at least I will put a little editorial here, which is, does it make sense for a body of law in which usually the people do not have very many resources to be one of this great degree of complexity? But I can at least reassure my colleague that the reason he thinks it's complicated is because actually it is really complicated. If I looked at the K-core at the start of the 20th century, it's quite a different picture. And our friend Gibbons versus Ogden, which seems to always appear, which is about a steamship, by the way, if anyone wants to know, is up there, as well as some cases that, frankly, once again, I do not know what Davis versus Gray is about. All right. So one of the other things we can look at are how do courts relate to each other? Are there clusters of courts that tend to cite each other? Are there courts that defer to each other? So we can come up with some notion of power within the court system. And it turns out, yeah, we can. So we can find the communities of a court-to-court graph, and we see sort of a main cluster here of the First Circuit Court of Appeals, which is one level below the Supreme Court in the federal system, SCOTUS, which is the abbreviation for the Supreme Court of the United States, the Seventh Circuit, the Ninth Circuit, the Fourth Circuit, the Sixth Circuit, the DC Circuit, from whence Brett Kavanaugh hails, the Second Circuit, the Third Circuit, and then we get into various state Supreme Courts and the like. And so this forms one fairly large cluster of power. But we also see regional clusters, like this is, I thought was interesting. This is kind of the New England cluster of New Hampshire, New York, Connecticut courts. We see the good old Texas cluster here, Texas Court of Appeals, Texas Court of Criminal Appeals, Texas Supreme Court, blah, 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 blah. New Jersey's in its own world. And so algorithmically, you can see just from the citation patterns how the communities of courts decompose. And we can make, of course, a nice picture of this showing the patterns of deference in American law, where this central cluster is basically the Supreme Court and the lower federal courts right below it. And we have various things feeding in, as well as courts that really seem to be off on their own, like the Idaho Court of Appeals kind of listens to the Idaho court, but Idaho, people leave it alone. So that is court-to-court citations. We can also look at what is the lifespan of a legal opinion. That is, these things have half-lives. They keep getting pinged and pinged and pinged, but after maybe 30, 40 years, they've been supplanted by some other opinion. And so one of the things I wanted to look at was the differential lifespan of citations by court. And it turns out that actually it's not so much the power of the court in some traditional hierarchy. It's whether it's at the top of its own system. So the New York Court of Appeals, that's the top court in New York. The Ohio Supreme Court, that's the top court in Ohio. The Supreme Court of Connecticut. These are mostly courts that are at the apex, and therefore they don't have other courts coming in and stepping over them. Whereas courts that are generally considered to be prestigious, like the DC Court of Appeals or the Ninth Circuit or the Fifth Circuit, the lifespan of their citations may be less because they are being stepped on by other courts. And so I thought this was interesting in thinking about the stability of the law. And if you want to know what's the average lifespan of a case, it's about 9 years. That's the half-life of a case, about 9 years. So what else can we do? I'm hoping to use structured arrays and structured data to get this data size down, because that has been the main obstacle to doing stuff. It's just really, this is data that, at least for me, is stretching my abilities in terms of its size. I was hoping we would have compilation available to work on associations, but I am told that is going to have to wait. I did some work with MongoLink, which I am very proud to say actually worked. The only problem was it didn't seem to be any faster. So I thought the complexity wasn't worth it, and maybe doing some parallelization with query and dataset. As I said, there is tons of work to be done here. This is just sort of it's not at the level of Steve Wolfram with his NKS telescope looking at the computational universe, not even close, but it's sort of the same thing. Here's this new data set that's out there that people have not probed before because they weren't as nice as I was to free.law. What do we see? What can we find from that? And so there are various projects, including better integration with other data sets, and I might play around with seeing if this is suitable for RDF and Sparkle. So that's what I got.